Hello everyone, let's continue the topic of circulation system, and as we discussed, the circulation system have multiple components, and these components including the mud pumps, mud pits, mud mixing equipment, contaminant removal equipment, all these are part of the circulating system. One of the most important part of the design of the circulating system is the mud pumps and selection of the mud pumps. So we need to get familiar with the calculations regarding the mud pumps. So usually these mud pumps are reciprocating positive displacement type of pistons, and there are two types of them: the 2-cylinder or duplex, and the 3-cylinder, which is called triplex pumps. The duplex pumps generally are pumps that are double acting pumps. When we talk about double acting, means that the pump both inject and there is a suction and there is an output, both in the forward and backward direction movement of the piston rod device, right? When we have a single acting, which you can see, this is an example of single acting pump that you see in this GIF. You can see that the fluid, when the forward movement is happening, the outlet is open, and when the backward movement is happening, the inlet is open. In any of these directions, either the outlet is closed or the inlet is closed. So this is a single acting pump. The double acting pump, on the other hand, is a pump that there are multiple input and outputs. So there are one more output here, and there is one more inlet here, right? So when the pump is moving backward as well, it does the the suction and output as well at the same time. So that is called the double acting pump, which we can see in the next slide. So the double acting and single acting pumps, you can see it in these pictures. The left picture is the double acting or duplex design, and not or the duplex. This is a duplex double acting design. So duplex could be single acting or double acting, but most of the duplex pumps are double acting. Most of the triplex designs are single acting. So you can see the single acting, there are only one inlet and one outlet. In double acting, there are two inlets and there are two outlets as well. So you can see the suction and discharge happening at both the forward movement and the backward movement. And one of the calculations we need to do here is to calculate the amount or the volume of the mud that is being injected, right? So in order to do those calculations, we need to define a couple of parameters, including the diameter of the cylinder, which is shown by dl, right? The diameter of the rod, which is shown with dr, the piston rod, right? And the length of the cylinder, which is defined by ls, right? So if you want to calculate how much volume you are injecting, then we need to do the calculations separately for the double acting or single acting pumps. So let's first calculate the displacement, and how much, as we call it, the displacement means that how much volume is being injected into out of the cylinder, right? So let's do calculations first for double acting pumps, and what parameters do you think are important here, and what volume is being injected initially? So for a double acting pump, we define these parameters: the piston rod diameter, the liner diameter. Liner is basically the same as this cylinder that I mentioned here, is the same thing, so we call it the liner diameter, and also the stroke length, right? The stroke length is the length of this cylinder. So when you do a forward stroke of each piston, then the volume that is being displaced is given by what volume? It's basically pi over 4, right? It's the when it's a movement, right, it's the whole volume of this cylinder, right? So it's pi over 4 dl squared multiplied by the length, which is ls, right? So this is one movement of one forward stroke, as we call it, right? On the backward stroke of each piston, then the volume displaced is how much? On the backward, you need to notice that there is a piston rod that reduces the total volume of the drilling fluid that is being injected, right? So that is going to be pi over 4, right? Multiplied by the length, of course, right? Multiplied by the cross-sectional area that is of the fluid that is being displaced, right? So the cross-sectional area is this part plus this part. So you should exclude the piston rod, and for doing that you just need to say dl squared minus dr squared, right? So that's a backward displacement, right? And of course this is a double acting, and that's why we are considering this one and this one both together, right? So the volume of the because the double acting again does the discharge on forward and also the backward movement, right? So this is the forward movement, this is the backward movement volume, right? Then you need to add these together, these two, for a complete pump cycle, how much volume would be injected, right? So one thing I need to do is to add these two together, right? So you can see these two equations that we put there, right? You need to add them together. One thing that you need to be careful here is that it's a duplex design, means that there are two of these, one and then there is another one acting at the same time together, right? So you have to add these together, right? Multiplied by 2, right? That is going to be pump displacement per cycle, or pump factor as they call it, okay? So pump factor, we show it with FP, which is the summation of these two multiplied by 2. And if you simplify enough, you get pi over 4 multiplied by 2, because you have two cylinders, multiplied by the length, 2 dl squared minus dr squared, right? But one thing that you need to be also considering is that these pumps are not really 100% acting, right? They have some overall efficiency. The overall efficiency of these mud circulating pumps is the multiplication of the mechanical efficiency and volumetric efficiency. So we define two separate efficiencies. The mechanical efficiency is usually assumed to be around 90%, and the volumetric efficiency could be as high as 100% depending on the manufacturing. The mechanical efficiency we show it with EM. The volumetric efficiency we show it with EV. Okay, so now here, since we are talking about the volume that is being displaced, we need to consider only the volumetric efficiency EV right here. So EV is called the volumetric efficiency, and FP is called the pump displacement factor. Okay, so that's it for this video. In the next video, I'm going to talk about the triplex pumps and how to calculate the pump factor for those pumps.